urbanization happening over the past few years. But today we are at a point where climate change is taking a toll on people with extreme heat conditions such as what we are experiencing right now. So can we draw lessons from the past, or are these past events enough for us to predict what's going to happen in the future? And how are we going to assess the current trends in this context?
Okay, so in your three-part question, my answer would be yes, we can draw lessons from the past, but the past is not sufficiently a predictor of the future. Therefore, we will need to find a new way of moving forward. What can we learn from the past? If you just build on what was just mentioned by Rohan, in Sri Lanka alone, over between 1990 and 2018, like about a 30-year period. Remember, 1990 is when the beginnings of the climate conversation was happening. 1992, the UNFCCC is initiated. In that 30-year period was $7 billion of damages from natural disasters. Right? Annually, about $240 million of flood-related disasters. Right? So you can immediately see the macroeconomic impact. Now, what, however, we can't learn is that those averages of the past, while they are shifting, what was an extreme event in the past is increasingly becoming normal. And what is an extreme event today becomes the norm in future. In climate change, I'll give you one phrase, non-linear risks. So basically, your risk curve does not stay flat. That you can't over time say, this is on average the number of floods I will have, or the number of cyclones I will face, etc. The risk curve starts shifting like that. It's non-linear. Which basically means that we have to start focusing on what is considered extreme today. And we start monitoring those. On the battlefield, as we say, you hope for the best, but you prepare for the worst. So how do you do this? That's the critical issue. Last year, I co-authored a paper in Nature Climate Change, in one of the world's leading scientific journals, and we saw that even the IPCC, many of the models, when it comes to South Asia, we don't get sufficiently accurate assessments of the risk because the models sort of stop at a certain level of resolution, and we need high resolution to understand not just within Sri Lanka, but different areas of Sri Lanka, how it might or might not get impacted. So the first thing we have to do is start collecting hyperlocal data. What is hyperlocal? Hyperlocal means you get down to the district level, the city level, and at some stage even at a ward level, at a neighborhood by neighborhood level. So let me just explain how we have tried to do this in India through CEW. We are building a climate risk and resilience atlas, which will be the first of its kind in a way in the developing world. Basically what we're saying is, first let's look at the past historical trends. So we have now gone back 50 years from 1970 onwards, and that's the basis on which we know that 75% of our districts have now become hotspots for these extreme events. But then we have to look at, are we prepared enough? And if not, how do we become prepared enough? So we've got to follow a framework which understands the exposure to these hazards, the sensitivity of the economic structure in that area. It could be an agricultural area which will face a certain sensitivity. It might be an industrial area where you might have, say, textile plants that might be at risk of flooding. An agricultural area might be at risk of drought. So you have to understand the sensitivity. And then you have to understand the adaptive capacity of that local area. That's the basis on which we are developing an index district by district by district. Another building block that we're putting in is heat and humidity action plans. So we've got about 120 odd cities in India that now have heat action plans. But just as you were saying, this variation within a day, in the morning you're sweating, in the evening it's raining. When you combine humidity with heat, what is called the wet bulb temperature, the experienced heat, so suppose it's 2 degrees warmer, the experienced heat becomes 5 degrees warmer. That then has an impact on how productive or unproductive the outdoor labor force becomes. So we have now designed a heat cum humidity action plan for one city in India to prevent all heat related deaths there in Thane, in Maharashtra. But we hope that using artificial intelligence, we can now scale that up to over 4,000 cities across India. The third building block is then industrial resilience. Mapping out how does your industrial structures, whether you have a food processing unit, a tea processing unit, a textile unit, what kind of topography they're under, what kind of stress they will feel, and then what might be the economic impact, even for a short duration event, but that might shut down the economic activity for several weeks. That means you lose that many weeks of economic output, exports, and so forth. So when we get granular, this is the how. What is happening? Yes, we know the world is on the boil. How we respond to it is really how we have to start leaning on each other, because it's in the global south that we are right at the interface of this triple planetary crisis of climate change, biodiversity loss, and pollution. But this is also the region where we have to create jobs and growth and infrastructure. Right? So marrying these two is really where the action will begin to happen in a hyper-local level.
Thank you, Dr. Ghosh.